Hey, I'm back. Um, I was doing a problem in the last video. I just left that out, so I just wanted to continue it. Um, so this is where we ended up, right? We got this expression and we found out two of the variables in the partial fraction expansion of this term right here. So we got b as 1 and d as 4. So we substituted that and it's not there. Just give me a minute, okay? Oh wait, there should be a 4 right there. What a mistake. Okay, there is a 4. Okay, yeah. So we need to find a and c, right? So what else can we set? We cannot set x equals to -2 or -4 because it won't get us anywhere, right? Because all the terms will cancel and we'll get something equals something, and we know that it is true, right? Something equals something. Yeah. So we need to set x equal to something else now. 0 sounds like a pretty easy number to deal with, right? So why don't we do that? We set x equals to 0, right? That is totally valid, as we set x equals to -2 and -4 in the last video. So if we set x equals to 0, what will we get? Here it'll be 0. Here it'll be 16 times 2 is 32 times a plus 16 plus 16c, that's a plus 16c plus 16. Okay, so if you simplify this, you'll get 2a plus c plus 2 equals 0. So that is my first equation. Now what else can we do? We can I'm kind of in the mood to set x equals to -3, right? Just to kind of see what happens. Okay, so on the left hand side we'll get 9. On the right hand side we'll get let's see, -a. I'll get 1. That's plus c. Yep, that is plus 4. Okay, so you get that -a plus c equals what? 4, right? Okay, so now you have two equations. This is my second one. You can solve these two linear equations to get your answer. I'll just multiply this by 2 and add these two up, from where I'll get that c equals 3c 4 plus that is 8 minus 2 6. So I'll get c as 2, right? Yeah, I'll get c as 2 and a as -2. Okay, let me check it if that satisfies what we want. Yep, that satisfies both of them. Okay, yeah, so let's proceed. Yeah, so we've got all of them, so let's just write it down. A equals -2 and c equals 2. So they kind of need results, you know, not too complicated, but yeah, it was lengthy. But now though I'll need one more video because that integration, we can do that, but it'll need some kind of explanation, right? So I'll just use another video. So if you can do it, just do it. Just don't watch it. But this is for people who really want the steps, right? Okay, so let's just write the integral. We found that this whole expression, x squared over x plus 2 the whole squared times x plus 4 the whole squared, can be written as what? That's a, which is negative 2 over x plus 2 plus b was 1, right? X plus 2 squared plus c was 2 over x plus 4 plus d was 4 over x plus 4 squared, and all of that times, that's a dx. Okay, now I'll do a couple of terms here, and I'll just explain, because I haven't done this type of integrals, right? 1 over something squared, x squared, basically. Kind of form is like that. So I'll just explain that in the next video. But I assume that you know this and this integral. Perhaps that will create some natural log terms and all that. You might know that. Okay, just I'll assume it and let's proceed. So that will become negative 2. Yeah, I mean, I can split the integral up, right? I won't write the dx because it's kind of too long. Okay, so I just split up the integral, and this term right here becomes negative 2 times the natural log of x plus 2. Alright, and this term right here, what will that become? That will become plus 2 times the natural, oops, it's horrible, natural log of x plus 4. Okay, and I'll do these two integrals in the next video. It'll be short. If you want it, you can see it, or if you know it, well, very good, it's very nice, and you can continue and complete this problem. For those of you who want to watch it, just watch my next video and see you then.